Hi everyone, this is example 10 on unsteady flow. A swimming pool is 20 meters long, 10 meters wide, 1.5 meters deep at one end of its length, and 2.5 meters deep on the other end. The change in depth between the ends being uniform. At the deeper end is a short tube with coefficient of discharge 0.605, 150 mm in diameter, which serves as a drain. Determine the time it takes to empty the pool if initially the level of water is 0.5 meter below the top edges of the pool. So we have the situation here, 20 meters long, perpendicular to the screen, it is 10 meters wide. So 1.5 meters deep at one end and 2.5 meters deep on the other end. The change in depth being uniform. At the deeper end is a short tube. So there's a short tube here, 150 mm diameter, which serves as a drain. So determine the time it takes to empty the pool if initially the level of water is 0.5 meter below the top edges of the pool. So at the deeper end, and on the bottom portion, of course. So because area S is constant for from this level up to this level, so we will call the time it takes to empty this part as T sub 1. And the formula is direct to area S quantity square root of HI minus square root of HF over C area O square root of 2G. So this is the formula, and it was derived in my lecture video on unsteady flow. So HI is the vertical distance from the drain to initial level, which is 2.5 minus zero point 0.5, so 2 meters. Therefore, 1.5 minus zero point 0.5, so this is 1 meter deep. So final level should be 1, initial level should be 2. So 2, this is 1. Substitute 2 times 20 times 10, quantity square root of 2 minus square root of 1 over 0.605 pi 0.075 square radius of the short tube, then square root of 19.62. So T1 is equal to 3,498.7 seconds. For T2, area S becomes variable, so let's call it T2, time to empty this triangular wedge part. This is our strip length is X, so the area S would be 10 meters perpendicular to the screen times X, so 10X. That's the area, and this is the head at any time. So expressing X in terms of H by similar triangle X as to H equals 20 meters as to 1 meter. This is 1 meter. So X therefore is 20H. Area S is 10 times X, and X is 28, so 200H. Area S is 200H. Substitute into the formula T2 equals integral of area S dH over C area O square root of 2GH or kautog. Then T2 is integral from 0 to 1 of 200H dH over 0.605 pi 0.075 square root 19.62 H. Calculating the constant 200 over quantity 0.605 pi 0.075 square root of 19.62. So we have a constant. Then the integral of H over square root of H is integral of H to the 1/2, which is H to the 3 halves over 3 halves, or simply 2/3 of H to the 3 halves. So T2 is 4223.308, that's the constant, then the integral 2/3 of H to the 3 halves from 0 to 1. Substitute T2 is 4223.308 times 2/3 times quantity 1 to the 3 halves minus 0 to the 3 halves, which is still 0. So T2 is 2815.5 seconds. Finally, the total time to drain the pool is 3498.7 plus 2815.5. So T is 6314 seconds. That's it for this problem.